Hi everyone, my name's Mickey. I'm your instructor for Math 65, and I received a few questions for Module 9 over WebWork, and I thought I would just take a moment to go over those. So these are all dealing with quadratic equations. So this one is from 9.2, number 45, and it says, consider two numbers where one number is 9 less than the other number. Find the pair of numbers such that that has the least possible or least product possible. One approach is to let x represent the smaller number and write an expression for the product of the two numbers and then find the vertex and interpret it. So the two numbers are, and we could figure out what those two numbers are and then what their least possible product would be. So if we're going to say x is the first number or just one of the numbers, we could either use x minus 9, 9 less than the second number, or we could just say x plus 9 would be the second number. It actually won't matter because it just matter which one is which. So when we're talking about the product, that's multiplication. So we're going to say x times x plus 9 is equal to y. Now if we graph this, another way of writing this is x squared plus 9x. And really what we want is to find the vertex. So since we want to know the least possible, when you graph this, if you were to go on to Desmos, you would see a parabola shape like this. And when we're talking about the vertex, then it's going to give us all the different possibilities of numbers that are going to multiply together. So the y values are going to be the products of the two values. And so if we're going to find the least possible product, we're going to find the vertex. And to find the vertex, we've learned that x equals negative b over 2a. So therefore, x will equal negative b is negative 9 over 2 times a, which is 2 times 1. So x equals negative 4.5. If I use negative 4.5 for one of the numbers, the first number, and then I plug in negative 4.5 in for x, then I would get negative 4.5 plus 9 is equal to 4.5. And if I multiply those two numbers together, so one of the numbers is negative 4.5, the other number is 4.5, and then if I go ahead and multiply those two numbers together, I would get, well, I can either use Desmos to check this or use my calculator to just go 4.5 times negative 4.5, and I'm going to get negative 20.25 for their least possible product. And if we did want to just take a look at that on Desmos, Desmos is coming up in chapter 10 anyway. So we could go ahead and go x times x plus 9. And then we're going to see this parabola shape all along. All the different points along here are going to be two numbers that multiply together. So negative 9 and 0 are going to multiply to 0, but a smaller product than that is going to be this vertex here. So one of the numbers is negative 4.5, and if you multiply that by 4.5, there's the product is part of the vertex, which is 20.25. Another cool feature of Desmos that you're going to find out is you can actually sign in, log in, or sign up for Desmos. So I've been using my PCC account, and what's great about that is it's actually going to allow you to save your graphs, and then you can also share them too. So I could title this one, maybe 9.2, oops, I'm at point 2, and this was, I think, number 45. And then you can also share the graph. So if you copy the link, you can share it with somebody else. Okay, let's go on to the next one. So I'm going to go back to my app here. And this one is 9.2, number 49. So you're going to build a rectangular sheep enclosure next to a river. There's no need to build a fence along the river. So I guess we're assuming that this is a rectangular enclosure, but we have a river here, and I guess our sheep don't swim. So you only need to build 3 sides. You have a total of 500 feet of fencing to use. Find the dimensions of the pen such that you can enclose the maximum possible area. One approach is to let X represent the length that runs perpendicular to the river. So if we call this X, this is also X, and then write an expression for the area of the enclosure. Well, if I know I have 500 feet of fencing total, if I take away these 2 sides, I would have 500 minus 2x. So right here, we're calling this the length, or it could be the width. Those are sort of interchangeable. And then we could call this the width of the pen. Now, to find the area, we have area equals length times width. So we're going to write area equals just the length, which is x, times the width, which is 500 minus 2x. And by the way, just to recap, we got that expression for the width because we wanted to say, well, we can't just use an unlimited amount, and we can't use 2 variables. So we're saying once I use a certain amount for this length and this length, well, I have to take those 2 lengths away from the total number of fencing. That's why I have 500 minus 2w. Okay, so find the vertex and interpret it. So because, again, if we graph this on Desmos, so let's say I go back to my Desmos here, and you could also create a new graph so that you might save it using those 9.2, number 49, in case we want to reference it again. So we're going to say that the area is x times 500 minus 2x. And what we're going to see here is that, well, we have to kind of play around with the dimensions. And what's nice on a tablet is you can kind of stretch it. If you wanted to really, zoom in and stuff, you can use these little tool icon to change the X and Y axis. But right here, this is going to give us the maximum value of X, which we said was the length. And then there's the maximum area. But to do this algebraically, that's just sort of to use Desmos as a tool to check our answers. But if we want to do this algebraically, let's go ahead and distribute the X. So we have area equals 500x minus 2x squared. Now, we noticed that was a parabola that was face down, and that's because the leading coefficient is actually the one that's attached to the x squared. So that's the area equals negative 2x squared plus 500. We have enough, 500x, sorry. We have enough information then to find the vertex. So to find the vertex, we're going to go x equals negative b over 2a. So now we have negative 500 over 2 times negative 2. That's going to be a negative divided by negative is a positive. We have 500 divided by 4, which is where we get the 125. So that means our length, x, is equal to 125. And then if we plug that value in here, we're going to find out what the width is. So 500 minus 2, we could say here's the width, is equal to 500 minus 2 times 125. And so we get 500 minus, oops, what's double 125? Isn't that 250? And then we get the width is actually, if I'm going to call that the width is equal to 250. So then the area is going to be 125 times 250, and that's where we get the 31,000, what was that? 31,225. So that's what you should get if you multiply those together. Whoops. Let me just double check that. So 125 times 250 equals, yes, oops, 31,250. And that would be, I don't know what we're measuring this in, feet. So this one would be in feet squared, and this one would be in feet. They might already have those measurements. No, it would be square feet. So the length of the pen parallel to the river should be 250, since this is parallel to the river here. And then the width, so I interchanged length and width, which is perpendicular to the river because that's the shorter side. Usually we call the width the shorter side. So that would be the 125 feet. And then here you have the 31,250 feet squared, cubic, or square feet. All right, let's look at one more in section 9.2, the key features of a quadratic graph, problem 57. So this one is a little bit tricky because they don't actually give you the formula, so you have to write the formula. But there's, yeah, so let's just go ahead and read this one over. So number 57 says, currently an artist sells 220 paintings every year at a price of $50 per painting. Okay, so they're going to make a certain profit, right? If you multiply the number of paintings times the amount they sell each painting for, then you could say, okay, well, for that year, they made $11,000. But they want to probably raise the price. So every time they raise the price by $10, they're going to sell 10 fewer paintings. So to obtain the maximum income, the artist should sell the paintings for a certain price. And then here we have to earn $17,000, which is going to be more income. Then they could possibly sell it for two different prices, a lower price and a higher price. So I just copied some of the solution down here. So what we might assume then is that the artist will raise the price per painting X times. So X is the amount of times they raise the price for the paintings. So the current price is $50, but they're remember they're going to raise the price by $10 every time. So every price increase counts for $10. So the new price is going to be 50 plus 10x is going to be the new price. So we have X being, right here, what we call this is defining the variable, define variable. Otherwise you would write that out. Okay, and then since they currently sell 210 paintings per year, and they'll get 10 fewer paintings every time they raise the price $10, then we can use this expression, 220 minus 10x. This is going to be the number of paintings. And remember when I said before that if you multiplied 220 times 50, you found that they got $11,000. That was their income for the year. So if we want to write an equation that would represent their income, the income is going to be equal to whatever the price is. So $50 plus 10x, and then the number times the number of paintings they sell, which is the 220 minus 10x. So again, we could look at this on decimals, but if we go ahead and FOIL this out, that's going to allow us to get the equation as a quadratic in standard form so that we're able to find the vertex, which is going to tell us, you know, the maximum income that they could make and the price that they could sell it for. So once we FOIL this out, we're going to get 50 times, well, I already did the 50 times 220, didn't I? This is equal to 11,000. That was the income that they would have earned. And then we have minus 500x plus 2,200x. And then the last term would be minus 100x squared. So this is their income. Okay, so now if I simplify this and I want to put my leading coefficient in front, I have negative 100x squared, and then I can combine my like terms in the middle, and that is going to be positive 1700x, because we have a negative here, and then plus the 11,000. Now, if I want to figure out the maximum income, that's going to be the vertex. So to find the vertex, I'm going to use x equals negative b over 2a. And in this case, negative b is negative 1,700 over 2a, which is negative 200. And if I simplify that, I have 1,700 divided by 200, and I get 8.5. So basically that means that I want to have 8.5 price increases because it's a positive, right? Does that sound right? Let's graph it actually on decimals just to be sure. So I like to just check this and make a new graph. And let's go, now I forgot the whole numbers. What was it? 50 plus 10x. Oops, that's the price. Times the number of paintings, which was 220, minus 10x, because every time you increase the price $10, you're going to sell 10 fewer paintings. And then we can zoom in. This parabola is going to open downward because of the negative coefficient of x squared. So here's our maximum. Oh, good. So 8.5, 18,225 would be the maximum income. So I got the 8.5, and if I take x equals 8.5 and I plug it back in to find my income, then I should get that answer, the 18,225. So that's the maximum income they can earn, 18,225 is the vertex. So to obtain a maximum income of 18,225, that's the first answer here, then the artist should set the price. How much should they set the price? Well, they're going to increase the price 8.5 times. So if we go back and we say, well, for the price, I need to plug that in, 50 plus 10 times 8.5. So essentially, they want to raise the price to 50 plus, if I move the decimal over because I'm multiplying by 10, I have 85. So they want to set the price at 50, what is that? 135. So the new price should be $135, and that will obtain a maximum income of 18,225. Okay. Now to earn a maximum income of 17,000 per year, the artist should sell paintings at 2 different prices. So what we're going to want to do is take our equation and set it equal to 17,000. We know that they can earn more than that, but we would be solving this for X. So in order to do that, you would want to subtract the 17,000 from both sides, and then you would want to use the quadratic formula. So once you set it equal to 0, you can plug it into the quadratic formula. A cool feature of Desmos here is if I do a second line and I say y equals 17,000, I get this horizontal line that crosses my parabola twice. So it basically means I can have 5 price increases, or I could have 12 price increases, and that would actually earn me the same amount. And that's because, you know, if I only increase the price 5 times, and what did we say? It was $10 every increase. So basically, if I increase the price from $50 to $100, then I'm still going to sell more paintings. But if I go ahead and keep increasing the price past my maximum, then I will sell fewer paintings. And so that's why I'm going to actually, even though I'm charging more, I will sell fewer paintings, so I'll actually make less money. So once you use the quadratic formula, and let me just see, maybe we should go ahead and use the quadratic formula. I was going to get on to these other problems, but let's go ahead and just review how we would use, oops, why don't I undo that? I'll just add a page in here. So if we take our formula, negative 100x squared plus 1700x plus 11,000 is equal to 17,000, because that's, remember, the income. And then to solve a quadratic, we're always going to want to start by setting that equal to 0. So I'm going to subtract the 17,000 from both sides, and I will get negative 100x squared plus 1700x, and then that's going to be negative 6,000, right? 11,000 minus 17,000, yeah, it should be 6,000, equals 0. So then to use the quadratic formula, I'm going to say x equals negative b, negative 1,700, plus or minus the square root of b squared, 1,700 squared. Now, actually, I'm realizing as I use all of these big numbers, I just want to show you a little trick, because this will make it actually a little easier. Because all of these are actually divisible by 100, my cat is meowing, and they're actually, the leading coefficient is negative. If you divide everything, both sides, by negative 100, you're just going to have smaller numbers to deal with, so you don't have to actually divide, or square, what was it, 1,700, which would be like a big number to square. The reason why you can do this is you're solving an equation, and it's not going to affect the 0, right? 0 divided by negative 100 is still 0. So what we can do then is we have, now our leading coefficient is 1. So we have x squared minus 17x, and then the 0 slash, plus 60 equals 0. And I'll just show you should get the exact same answer. And even if you graph this, what you're going to notice is that you'll still have the same x-intercepts, even though this is a different graph. So we'll have x equals negative b, which is 17, negative negative is a positive, plus or minus the square root of negative 17 squared. And by the way, that will always end up being positive because we're going to square a negative, minus 4 times a, which is 1, c, which is 60, all over 2 times a, so 2 times 1. So here we have 17 plus or minus the square root. 17 squared is 289, and then 60, we have minus 240, 24 time, and then with a 0 on the end, because we have 4 times 6 is 24, divided by 2. And then once we go ahead and subtract these, we end up with 17 plus or minus the square root of 49 over 2. And then since 49 is a perfect square, we have 17 plus or minus 7 over 2, and we can split that into two different answers. So 17 plus 7 over 2 is 24 over 2, which is where we get the 12. And then 17 minus 7 over 2 is going to be 10 over 2, which is where we get the 5. Now remember that these are not the price. These are the number of price increases. So if we go back up to the problem, it says to earn $17,000 per year, the artist could sell his paintings at two different prices. The lower price would be, it would be that, because right here we're using this as the price. And so we would have 50 plus 10 times 5, and that would be, so that'd be $100, and that would be the low price. And then, or remember, it can go up past the maximum, so it would be 50 plus 10 times 12, which is 50 plus 120, so that would be $170 for that new one. Okay, so that concludes the 3 questions I received on 9.2. I'm going to do another video for the next set.